All right, welcome back to Mr. Piels with Precal. This is Unit 3, Topic 1, Lesson 4. We're going to do an introduction into the unit circle and finding all the trig functions of various different angles. All right, so starting off with a warm-up, and this warm-up kind of leads to what we've been doing before, which is matching our degrees to our radians, which, if you keep in mind that 30 degrees is really pi over 6, and you know that you multiply that by 10, so if pi over 6 is 30 degrees and 300 degrees is just 10 times 30 degrees, then 10 times this. But then remember, 10 pi over 6 can be simplified to 5 pi over 3. So little tricks to figuring out things that you may or may not know. So if every pi over 2 is every 90 degrees, so 1 pi over 2, 2 pi over 2, 3 pi over 2 would be 270 degrees. 3 pi over 2 is here. 45 degrees is halfway to that, so it's halfway to half, so that would be 1/4. So this is 1/4 pi. And now, just like I did this one prior here, so 150 degrees is really 5 sets of pi over 6, because pi over 6 is 30 degrees, and if you multiply that by 5, 5 times 30 is 150 degrees. So multiply this by 5, you get 5 pi over 6, which is right here. 210, I'll do the exact same trick, because pi over 6 is 30 degrees, but if you multiply 30 degrees times 7, you get 7 pi over 6. 7 times 30 degrees is 210 degrees. And just by simple process of elimination, then 135 has to be 3/4 pi. Trick there would be 45, 45, 45. It's 3 sets of 45s. Now, if every 45 degrees is pi over 4, and 3 times pi over 4 is 3 pi over 4. Okay, so now here's the unit circle. We're going to start off by just doing some of it and talking about the parts that I really just explained in the warm-up. So if we know that this is 0 degrees, which is, let's say 360 degrees all the way around, and that's 2 pi, because we know that this radius is 1. So it's 2 times pi times radius would be the circumference of any circle, as you learned back in geometry class. So half of that would be pi. So I'm going to put pi right here, which is 180 degrees. And then half of that would be pi over 2, which is 90 degrees. And this would be 270 degrees. So that's 1/2 pi, 2/2 pi. This would be 3/2 pi, or 3 pi over 2. So that's going all by 90 degrees. Now, if we break it down into 45 degrees, so here would be halfway to the 90-degree point. So if this is pi over 2, then this is pi over 4. So this is 1/4. Right here, this is 1/4, this is 2/4, this is 3/4 pi, which happens to be 135 degrees. 4/4 pi, this will be 5/4 pi. 6/4 pi, this is 7/4 pi. Gotta do the math here because I don't have these memorized. So this is 180 plus 45 and make 225 degrees. I don't have the degrees memorized. Add 45, give you 270. Add another 45 here, you get, what is that, 315 degrees. Okay, so now I'm going to do the 30 degrees. So this is 30 degrees, this is 60 degrees, this is 90, this is 120, this is 150, this is 180. Okay, so now every 30 degrees, as I mentioned during the warm-up, is pi over 6. So that's 1/6 pi. This is 2/6 pi, which is really pi over 3, because 2/6 is the same as 1/3. This is 2/6, this is 3/6, this is 4/6 pi right here. 4/6 pi is really 2/3 pi. 4/6, this is 5/6 pi. 6/6 pi, this would be 7/6 pi. This would be 8/6, which is really 4/3 pi. 9/6 pi, 10/6 pi, which is really 5/3 pi. 11/6 pi. And then obviously 12/6 pi. 12/6 is really 2. The 30 degrees, so if I keep adding the 30 degrees, that'd be 210. This would be 240. This is obviously 270. Add another 30, you get to 300, and then 330, and then 360. Okay, so, all right, so you know what? I'm going to go back and I'm going to label these separately. So this could either be 0 degrees, which is 0 radians, or it could be 360 degrees, which is 2 pi radians. All right, so now we've done all the insides. Now, what we haven't done is the outsides. Now, That's going to come with today's lesson, and I'm going to have to probably break this up into 2 videos. I'm 5 minutes in. This is a pretty long lesson. Please understand that this is 1 unit is the radius. Now, we've already identified the fact that sine is y over r and cosine is x over r. Now, the reason why that's important is because if r is 1, if the radius is 1 for all circles, because that's the radius of the circle, no matter which direction it's going in, then cosine is really just x, and sine is really just y. So whatever we get of that angle, so if we say sine of 30, then we're just going to put that in the y spot. And x, cosine of 30 would end up being the x. So we'll just put that right here. So this will actually be the cosine, and this will be the sine all the way around, because as I mentioned, cosine is x over r, and if r is 1, then the cosine of that angle is the x of that point. So these represent the points of where they're at around the circle. All right, so how did you find the exact values? So you're going to have to memorize 30, 60, and 45. So those are the, off from pressing 1 button. How can you find the exact values of 30, 45, and 60? So if I give you an equilateral triangle, that means that this side's 2, this side's 2, and this side's also 2. If this side's 2 and it's split up into half, then each side of this half will be 1. So imagine I took this equilateral triangle and I split it into half itself. Now, if it's an equilateral triangle, we know that all angles are 60 degrees, which means we know this is 60, we know this is 60, we know this is 60, but it's split up into 2, because keep in mind, we're going to split this equilateral triangle into 2 right triangles. Trigonometry has to be a right triangle, which means this is 30 and this is also 30. And since we've made it into a right triangle, then we know this is 90. So these are both 30, 60, 90 triangles. So that's the measures of all 3 of these. Now, we know this side's 2, we know that side's 1 because it's halfway the distance, but we don't know the side of this other leg. So we're going to find that other side. So that's a squared plus 1 squared equals 2 squared. So a squared plus 1 equals 4. Subtract 1 from both sides, you get 3. And then you square root both sides, so you get square root of 3. Okay, so this leg squared, so this would be 3, this would be squared would be 1, 3 plus 1 is 4, and that equals the 2 sides squared. So, all right, so now we know what this side is. Now we can figure out all these lengths. So cosine of 30, I'm going to use this bottom triangle. That'd be adjacent, which would be square root of 3 over the hypotenuse. So cosine adjacent over hypotenuse, which is 2. Sine would be 1 over 2. And tangent would be 1 over square root of 3. Now, this needs to be radicalized by multiplying both top and bottom by square root of 3. So it ends up being square root of 3 over 3. Cosine of 60. So now I'm going to do this side. So that would be 1 over 2. Sine of 60 would be square root of 3 over 2. Now, keep in mind that this should not shock you that these 2 and these 2 are the same, because it's just using the opposite angle. And then tangent of this is going to be the exact same but the reciprocal, so that would be square root of 3 over 1, which is just square root of 3. No reason to radicalize that because it's over 1. It does not have a radical symbol in the denominator. Okay, so we've actually come up with a lot of the answers. So cosine of 30 is square root of 3 of 2. Cosine of 30 is square root of 3 over 2. And it's just going to take some back and forth here. So sine of 30 is 1/2, which, keep in mind, that also means that cosine of 60 also happens to be 1/2. And it also means that sine has to be square root of 3 over 2. Sine of 60, square root of 3 over 2. And then we have tangent of 30 is square root of 3 over 3. Tangent of 30, square root of 3 over 3. And then this just, if you do that backwards, and then we also got square root of 3 for tangent of 60. All right, and you can say this is over 1. So now, to find these, you would just simply flip it. So cosecant is the reciprocal of sine, which would be 2 over square root of 3, but keep in mind that's not right, so that ends up being 2 times the square root of 3 over 3. And flip this, you get just 2. Flip this, you get 1 over square root of 3, which doesn't work. Multiply top and bottom by square root of 3, you get square root of 3 over 3. All right, flip this, you get 2. Flip this, you get 2 over square root of 3, which once again doesn't work. And we already know because we did it right here. That's 2 times the square root of 3 over 3. And then cotangent, flip this around, you get 3 over square root of 3, which then radicalize that, so you get 3 times the square root of 3 over 3. All right, so it's this. So just keep in mind that these are the ones that we are going to be using. So 45, we haven't done 45 yet, and yeah, I'm already at the 10-minute mark. I'm definitely going to have to make 2 videos of this lesson. Let's look at the isosceles right triangles. So we know this is 45 degrees, this is also 45 degrees. 45 plus 45 plus 90 equals 180. So we need to find out, well, if this is the radii of the circle, then we need to figure out what this side would have to be. So that's 1 squared plus 1 squared equals the c squared. So 1 plus 1 is 2. Square root of both sides means this side is square root of 2. All right, so sine of 45. So we can use either side. It really doesn't really matter. So that's 1 over square root of 2, but once again, radicalize that becomes square root of 2 over 2. Sine of 45, square root of 2 over 2. Cosine would be adjacent over hypotenuse, which is the exact same thing. So we know this is also going to be square root of 2 over 2. And then tangent of 45 would be 1 over 1, which is just 1. Okay, so now if you flip those, yeah. All right, so then if I flip this, becomes 2 over square root of 2, 2 over square root of 2. Remember, multiply both top and bottom by square root of 2. You get 2 times the square root of 2 over 2. Now, keep in mind that those 2's can cancel out, and I kind of missed that on this one over here. These 3's can cancel out, just be square root of 3. Because the 3 and the 3, they're both factors on top and bottom. They can be simplified. So cosecant, so that would be 2 over square root of 2. Okay, it's the exact same thing, so you know it's going to be just square root of 2. It's going to be the exact same answer. Then cotangent, if you flip 1 over 1, you get 1. All right, I think I'm going to have to stop right there. 12 minutes in. So what I would do next, actually no, before I stop this, I would then, for the first quadrant, I can then transfer my answers over to here. So if it's a 30-degree answer, so I'm looking for cosine here and sine here. So 30 degrees, sine is 1/2, and cosine is square root of 3 over 2. All right, so that would be square root of 3 over 2, comma 1/2. Square root of 3 over 2, comma 1/2. That's cosine, comma sine. And then I'll do the same thing for 45. So 45 degrees, 45 degrees would be square root of 2 over 2 and square root of 2 over 2. So it's the same no matter what. Square root of 2 over 2 and square root of 2 over 2. And then keep in mind that 60 degrees is going to be the exact same, but in reverse. So this is going to be 1/2 and square root of 3 over 2. I can prove that. We go back to 60 degrees. You'll see that it's 1/2, comma, square root of 3 over 2. And yeah, 90 degrees, which... yeah, undefined for this. I'm just going to leave it like that for now. So keep in mind the quadrant 1 is always positive, so it's always positive to the right and always positive up. Now all of these, these 3 and these 3 and these 3 are going to be the same, only they're going to be the same as these 3 right here. Remember, we've talked about reference angle, so if this is 30 degrees, then this is going to be the same as this. So this right here will go right here, square root of 3 over 2 and 1/2. But the only difference is that if we're talking about sine and cosine in the second quadrant, remember this is all of them are positive, only sine is positive, only tangent is positive, and only cosine is positive. So in this case, only sine is positive, so cosine is negative. So this is going to be negative square root of 3 over 2, 1/2. Now, if I put that same number, square root of 3 over 2 and 1/2, then keep in mind these are both going to be negative because only tangent is positive. So sine, cosine and sine are both going to be negative. And then I'm going to put the same answers here, square root of 3 over 2 and 1/2. But cosine is positive in this one, so this one stays positive and the sine goes negative. And I'm kind of running out of time here. I know that's a lot to take in right here at the very end. I'm going to have to stop the video. I will do the exact same for all the others for the 45s and the 60s. Thanks again for watching. Have a wonderful day.